Hi everyone. Next we'll see the functional transform. So simply we can say that is a Laplace transform of a specified function of t. So we'll limit this introduction of this Laplace transform to the unilateral or one-sided functions. That is, when t is less than 0 minus, it should be 0. The function, all the function to be 0 for t is less than 0 minus. It will exist only from 0 to infinity. So first we'll take few examples like the function. The first function is the unit step function. F of t is equal to u of t is the unit step function. U of t, what is a step function definition or mathematical representation? U of t, unit step function means u of t is equal to 1 for t is greater than 0 and it is 0 for t is less than 0. U of t is existing only for t is greater than 0. So now we'll find out the Laplace transform of f of t. Laplace transform of L means, capital L means Laplace of f of t. So what is the definition? Actual definition is minus integral minus infinity to infinity f of t into e power minus st into dt. But as we are limiting only to the unilateral or one-sided function, we'll consider only 0 to infinity f of t into e power minus st. That is, if you are multiplying the function with e power minus st and integral over the 0 to infinity, that is your Laplace transform of the one-sided function. So I'll substitute what is f of t here. Unit step function means what is f of t? 1. So I'll substitute the function here. E power minus st is multiplied with the function and integrating over the 0 to infinity into dt. So what is the integration of e power minus st? Here e power minus st is nothing but t coefficient is minuses, right? So e power at integration is nothing but e power at by a. Here a is nothing but minuses. So e power minus st by minuses, and substitute the limits, time limits from 0 to infinity. If we substitute infinity, e power minus infinity by minuses, and 0 means e power minus 0 by minuses. So e power minus infinity is nothing but 1 by e power infinity, 1 by infinity, which is equal to 0, and here e power 0 is equal to 1, minus 1 by minuses, which is equal to 1 by s. So Laplace transform of unit step function is 1 by s. So if you have any k unit, that will become k by s. The second function is exponential function. So that is f of t is equal to e power minus at. So in the same Laplace transform equation, Laplace transform of f of t is equal to integral 0 to infinity f of t into e power minus st into dt. I'm replacing this f of t with the e power minus at. So integral 0 to infinity e power minus at into e power minus st into dt. Both bases are same, powers will be added, e power minus of x plus a into t into dt. So just like similar to the earlier derivation, like integration of e power k into t, which will become e power kt by k. So e power minus of s plus at as usual by minus of s plus a, that minus I am writing here. So substitute the limit 0 to infinity, minus of 1 by s plus a, here e power minus infinity minus e power 0, e power minus infinity minus e power 0. E power minus infinity is equal to 0, e power 0 is equal to 1, minus 1 into minus 1 plus 1, 1 by s plus a. Laplace transform of e power minus at is equal to 1 by s plus a. In this way we can find out any function Laplace transform. Just you substitute the function with its mathematical representation. If you want to find out the Laplace transform of unit step function, we have replaced f of t with the 1. If you want to find out the Laplace transform of f of t is equal to exponential function, e power minus at is substituted in place of f of t, and do the integration, substitute the limits. In a similar way, we'll see one more, the cosine function. So cosine function f of t is equal to here, f of t is equal to cos omega t. Laplace transform of f of t is equal to integral 0 to infinity f of t into e power minus st into dt. F of t I am replacing with the cos omega t. So here, if I rewrite this equation, integral 0 to infinity e power minus st, how do I write the cos? I don't have direct equation like integral e power minus st into cos omega t. So I'll rewrite this cos omega t like, what is e power j omega t? E power j omega t is nothing but cos omega t plus here exponential to polar form to complex form representation. E power plus j omega t is nothing but cos omega t plus j sin omega t. E power minus j omega t is nothing but cos omega t minus j sin omega t. E power j theta is equal to cos theta plus j sin theta. So polar form to complex form. By using that, I need only cos omega t, right? To have the cos omega t, I'll add both of them so that this j terms will be cancelled. Add and divide with the 2, because I'll get, when I'm adding, I'll get the 2 cos omega t, right? So e power j omega t plus e power minus j omega t by 2 can be represented with the cos omega t. Now I'll multiply this e power minus st inside this bracket. So this 1 by 2 I'll take it outside. Integral 0 to infinity e power minus of, if I take s minus common, s minus j omega of t into dt, integral 0 to infinity e power minus of s plus j omega, because both minus are there, minus, if we take common, s plus j omega of t into dt. If you do the integration of e power k into t, again e power kt by k. K is nothing but here minus of s minus j omega. This minus I have written at the numerator. And I'll substitute the limits 0 to infinity. In a similar way, I'll do the integration and substitute the limits. If I substitute these limits 0 to infinity, I'll get 1 by 2 of 1 by s minus j omega plus 1 by s plus j omega, which I can simplify it as s by s square plus omega square. So Laplace transform of cos omega t is nothing but s by s square plus omega square. In this way, you can find out the Laplace transform of any function. So this is all about the finding out the Laplace transform of the functions.